Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 31, Limits and Continuity. Before you can differentiate or integrate anything, you must answer one quiet question. Where is this function heading? As its input creeps toward a value, that destination is the limit, and remarkably, it can exist even at a point the function never actually reaches. From limits grows the idea of continuity, a graph you can draw without lifting your pen. Master the one-sided limits, the standard results, and the three ways a graph can break, and you unlock the whole of calculus. Today, limits, their evaluation, and continuity. One idea at a time. Here is what you will master today. First, the idea of a limit. Second, one-sided limits and existence. Third, standard limits and indeterminate forms. Fourth, continuity at a point. And fifth, the types of discontinuity, one idea at a time. Let us set the foundation. A limit. It is where a function is heading as the input approaches a value. Not the value. The limit can exist even at a point where the function itself does not. Continuity. A function is continuous if its graph has no break. Master line. The limit is the foundation of all of calculus. Now look at the picture. The limit. A limit, it is the value that f of x approaches as x approaches r, and it need not be f of r. One-sided limits. There is a left-hand limit approaching from below and a right-hand limit approaching from above. Existence. The limit exists only if the left and right limits are equal. The whole, the function, need not even be defined at a for the limit to exist. A hole in the graph changes nothing. Now, how we actually evaluate a limit. Direct substitution. If f of r is defined and finite, then that value is the limit. Factor and cancel. For the 0 over 0 form, factor the top and bottom and cancel the common term. Rationalize. For third forms, multiply by the conjugate. Standard limits. Learn that sine x over x tends to 1 and 1 plus 1 over n all to the n tends to e. Now, the indeterminate forms and how to break them. The forms. 0 over 0, infinity over infinity, 0 times infinity, and 1 to the power infinity. L'Hopital's rule. For 0 over 0 or infinity over infinity, differentiate the top and the bottom separately. The exponential form. For 1 to the power infinity, take the logarithm first. Maybe sine x over x. As x tends to 0, sine x over x tends to 1, the most used standard limit of all. And e to the x minus 1 over x tends to 1, as does the natural log of 1 plus x over x. Now look at the picture. The three types of discontinuity. Removable. The limit exists, but f of a is missing or has a different value. A single hole in the graph. Jump. The left and right limits both exist, but they differ, so the graph takes a step. Infinite. The function shoots off to infinity, a vertical asymptote. Continuity. A function is continuous at exactly when the limit equals f of a. Now continuity, made precise. The definition. F is continuous at a if the limit, as x tends to a, equals f of a. Three conditions. First, f of a exists. Second, the limit exists. And third, the two are equal. On in interval. A function is continuous on an interval if it is continuous at every point of it. The algebra. Sums, products, and quotients of continuous functions are continuous wherever they are defined. Composite. And a composite of continuous functions is itself continuous. Now, the standard limits worth memorizing. Trigonometric. Sine x over x tends to 1 and tangent x over x tends to 1 as x tends to 0. Exponential and log. E to the x minus 1 over x tends to 1 and the natural log of 1 plus x over x tends to 1. The number e 1 plus 1 over n or raised to the n tends to e as n tends to infinity. Now match each idea to its result. the left limit equals the right limit goes to, the limit exists. The limit equals f of a goes to, continuous at a. A single hole goes to, a removable discontinuity. And sin x over x, as x tends to 0, goes to 1. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. A limit can exist where the function is undefined. Correct. Statement 2. Continuity requires only that the limit exists. Wrong. The limit must also equal f of a. Statement 3. Sin x over x tends to 1 as x tends to 0. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the continuity condition in statement 2. Now, the two mistakes that quietly cost marks. The truth, the limit exists when the left and right limits are equal. The trap, assuming the limit always equals f of a, that holds only when f is continuous. The second truth, for 0 over 0, factor, rationalize, or use L'Hopital's rule. The second trap, applying L'Hopital to a form that is not actually indeterminate. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. When does a limit exist? When the left and right limits are equal. Question 2. The condition for continuity, the limit equals f of a. Question 3. Sin x over x, as x tends to 0, 1. Question 4. A hole in the graph, a removable discontinuity. And question 5. 1 plus 1 over n, all to the n, as n tends to infinity, e. Let us gather it all in one breath. A limit is where f is heading, and it may exist where f is undefined. The limit exists when the one-sided limits agree. Continuous at a means the limit equals f of a. The discontinuities, removable, jump, and infinite. Sin x over x tends to 1, and 1 plus 1 over n, all to the n, tends to e. Next class, differentiation, the derivative and its rules. The gateway to calculus. Everything in calculus begins here, with a single, patient question. Where is the function heading? The limit answers it, and it does not care whether the function ever arrives. A hole in the graph changes nothing. When the left and right limits agree, the limit exists, and when that limit matches the actual value, the function is continuous, its graph unbroken. Learn the standard limits by heart, spot the indeterminate forms, and name the 3 ways a curve can break, and the door to differentiation and integration swings open. Next class, the derivative itself. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.